we're going to review and understand the principles of incineration. So incineration is also called waste to energy, and is a combustion process where oxygen is used at high temperatures to liberate energy in waste. The most important advantage of incineration technology is the size reduction that eases the problem of waste dumping. Reducing landfill space requirements of at least 75% on weight basis and 90% on volume basis. So basically, organic matters are reduced to ash. You can see on the figure, this is a general figure of an incineration plant where the waste is burned, and then one of the products, the end products, is the ash. That can contain metals and other elements that are not destroyed, and this energy is being used for to generate electricity. We have also the liberation of the gases, and this is one of the main drawbacks of the process when the gases are not treated prior to emission. As I said before, the ash also can contain toxic elements, so also treating ash or a proper disposal is important. Incineration is a process that is more favorable for wastes that have a high energy content, low moisture content, and low ash content. So the ideal material for incineration can be paper, plastic, textiles, leather, and wood. The yield of energy from combustion is measured as the calories of heat liberated per unit weight of material burned. This is the heat of combustion, or in engineering terms, the heat value. In order to assess the fuel characteristics of a particular waste, we need to have these values: ash content, moisture content, and combustible content percentage, and also the energy value of the waste. So as you can see, it is clear that, for instance, food and organic waste will be very difficult to incinerate on its own due to the high moisture content, while other materials are better for incineration. And even if glass, metal, these materials do not contain high moisture content, of course the combustible material is null. From this information that we get from the components, or that we can find, we are going to calculate the lower calorific value. So since the heating value of municipal solid waste is an important parameter in the decision-making process, lower calorific value for each type of waste is important. We're going to calculate this through this formula. As you can see, this formula on the left side requires information on the energy value that was on the table, and also on the combustible value. And then these values are, we need to take out the energy that will be required, will decrease or will be diminished due to the heat of vaporization of the moisture of the water, that is water content of the components. All right. So the right side of the equation contains the heat of vaporization and the moisture fraction. By weighting these individual the energy values for each type of waste with the percentage wet weight, the overall lower calorific value can be found. And I'm going to explain now why this is important. So according to the World Bank report on incineration plants, and also as general, the average lower calorific value of the municipal solid waste must be at least between 6,000 and 7,000 kilojoules per kilogram throughout all seasons in order to be feasible. All right. The wastes which are theoretically feasible for combustion without auxiliary fuel, because the information that we're going to get from this heat value is whether we will require additional fuel or not. But then it also the waste also have to meet the limits in terms of water, ash, and combustible matter contents. All right. So how are we going to define whether these requirements are met? We can use this Tanner triangle, and this is used to check whether municipal solid waste can be burned. According to the Tanner triangle, the wastes that are theoretically feasible for combustion without auxiliary fuel should have met the following limits. So the limits are moisture content lower than 50%, ash content lower than 60%, and combustible fraction higher than 25%. This means that everything that is inside this area in the triangle cannot be combusted without the need of additional auxiliary fuel.